Hi guys, welcome back for the next part 3.4 under free falling. Okay, free fall. So object that is under free fall is an object that is under the influence of Earth's gravity. Okay, free fall is the motion of an object under the influence of gravity. Okay, so you already know the gravity is 10 meter per second, but there's an average value, so it depends on what value you're asked to use. 10 is a round out value, the actual value is 9.81. Average value 9.81, but in equator, like our Malaysia here, roughly, especially in Kuching here, your value will be 9.77. Okay, from experiment and also from some theoretical calculation. So free fall means object falling down when you release it. Okay, it's under the influence of gravity. In this case, it is the weight of the object that is actually pulling it down. Okay, so this is the Earth surface. So everything that is on the surface, okay, at a distance from the surface, when you let go, the weight will actually pull it down, and it is under the acceleration of the Earth. So this acceleration is equal to g. Okay, is equal to g. And what is our g value? The magnitude of our g is equal to 9.81 meter per second. But because acceleration is a vector, our g, okay, is negative 9.81 meter per second. Okay, negative means downwards. Okay, down. The acceleration is always down. Now this direction is a vector direction now, compared to previously the car acceleration, which is negative. It simply means your velocity is actually reducing. But this one, it simply means that your acceleration is downwards. You are accelerating at 9.81 but downwards. Alright, so that means anything you put on at the distance from the surface of the Earth will be accelerating at the same value, but of course it has a certain condition. No air resistance. Okay, no air resistance. So to use this value, no air resistance, and it cannot be too high. What is the actual value that you can, actual height that you can still use negative 9.81? Well, it's roughly like 10 kilometer. Okay, 10 kilometer. Anything more than that, I think the error will be quite big. Okay, if you go up to about 100 kilometer high from the surface of the Earth, your g value definitely will be much smaller than 9.81 negative. It may be like negative 9.20 and so on, or maybe even negative 8 point something. Okay, so we're going to use the same kinematic equation. Okay, our original kinematic equation is like this. Okay, the original kinematic equation is v equal to u plus at, v square equal to u square plus 2as, and then our this next one is s equal to ut plus half at square, and our s is equal to half u plus v times t. So now under free fall, our kinematic equation become v equal to u plus gt, v square equal to u square plus 2gs, and then s equal to ut plus half gt square, and the one that does not change is this one, the fourth one. Alright, well, it's actually the same. The only thing is now your g is a fixed value of negative 9.81 meter per second. Whereas in this one, a is a constant but at any value. Okay, it's a constant, but it's a value. If it is 2, it's all the time 2. If it is -4, it's all the time -4. But for free fall, there's only one value. Near Earth surface is -9.81. Okay, so it's the same usage, except there is something that I want to mention here is this. Under free fall, let's say object falling down from the sky. This is the Earth surface. Okay, object that is falling on the surface of the Earth. Okay, under its own weight. Well, we have to follow our coordinate system. Okay, we have to follow our coordinate system. Going up, any value that is pointing up is positive y. Anything that point down is negative y. So that means when an object is falling down, two things is negative. Number one is acceleration, definitely negative. It's all the time negative. That one we cannot argue. The next one is the velocity. It's moving down faster and faster, so the velocity is getting more and more negative. Okay, so that negative represent the direction. So you learn coordinate system, so now use that system to help you solve the problem. Okay, so now if this object initially is from this location, so by the time it reaches the Earth's surface, this is actually the displacement. And since displacement is a vector, so now your displacement is negative. In this case, the velocity is also negative, and the acceleration, which is equal to g, is also negative if it is coming down. Okay, but if you throw things up, your velocity is negative. Okay, for example, this is a second scenario. Okay, the second scenario is this. Object is being thrown up. Okay, you throw the object upwards with a certain velocity. Well, now your velocity is positive. If you reach a certain height here, let's say you reach here. This is your new location now. So from here going up, your S is also positive. But why you slow down? You slow down because of the Earth's acceleration, which is negative. So your A is still G, which is again negative. You see, these are constant. Okay, the rest can change depend on how the thing moves. Is it up or down? All right. So that is a thing that you have to remember. Positive y and negative y. You use that, you won't make any mistake in defining your final answer. Okay. So we look at a few examples on how to solve the problem here. This is our page number 4. Okay, example on free fall. Okay, example on free fall. That is example 1. First, start with example 1. Okay. Now example 1 will be we drop something. Okay, a stone is dropped from a height of 280 meters. Okay, when you drop something, your initial velocity is 0. Okay, so a stone is dropped from a height of 250 meters. Calculate two things here. Number one, the time. Calculate the time taken to reach the ground. And then B is the velocity of the stone upon impact. That means the before it the time it hit the ground, what is the velocity? Okay, so you'll be given normally the G is negative 9.81 meter per second per second. Okay, we're going to calculate two things here. Okay, now number one is A. List down what you are given. A stone is dropped, U is equal to 0. And then it is dropped from a height of 250. By the time it reached the ground, it is lower than the initial position. So the displacement is negative 200 meters because it's coming down, right? And then our acceleration is g, which is negative 9.81 meter per second. And from here, you can calculate the time t. Okay, the time t is what you need to find out. So what is the time t? How to get it? S is equal to ut plus half gt squared. This one is negative 2 at 0. This one is 0 because initially 0 plus half negative 9.81 and t squared. Okay, so we use calculator to find out the value here. So we have 2 at 0 multiplied by 2 divided by 9.81. So our answer will be 57.1 seconds. Okay, 57.1 seconds. Alright, so that is how long? Roughly about 1 minute. Alright, now number 2 is the velocity of the impact. So we have this U, S, and A. We need to find V, so we use a second equation. So our V is what we want to find, and then our U is 0, and then plus 2 negative 9.81, and then multiply by negative 2 at 0. So let's see what we have here. The square root of something here. 2 times 9.81 times 2 at 0. Okay, we have this 5493.6. So finally we have this square root. We have plus minus, got two answer, plus or minus 74.1 meter per second. But which one we choose? Because it's coming down, right? So coming down we have a negative value, so V is equal to negative 74.1 meter per second, pointing downwards, negative. Guys, remember vector direction is important. Okay, so that is one. Okay, next one, example 2. More difficult now. Okay, you are at the edge of a cliff, and it is a seawater here. So you throw something up, a stone. You throw the stone up at an initial velocity of 40 meter per second. Okay, so this stone, of course, will finally go up slower, reach the final, the maximum height, and then of course you'll come down again, and of course hit the water here. There's a shark here. Okay, now the height of the cliff, this one here, the height of the cliff is 100 meter. Okay, 100 meter. So you throw, go up, reach the maximum height, and then reach the sea surface, 100 meter below the cliff. All right, so calculate few things here. Calculate A. Okay, calculate A, the time in flight. What is that? Time in flight means from here until it reach here. Okay, time in flight. And then B, the maximum height from the cliff. How high is this one? Okay, and then C, the impact velocity. Impact velocity is here. Okay, is here. So we have 3 things to calculate here. Okay, time in flight, A. So we list down what we have. Going up, you have U equal to positive 40 meter per second. And then you have A equal to negative 9.81 meter per second. And then the displacement. What's the displacement? When you are from here, go to here. Your displacement is here, right? So it's equal to negative 100 meter. That is the height. But you are from here, you reach here. Displacement is final position minus initial position. So you have a vector here. That is your displacement. So I'll use the red color one to show you the displacement. This is your displacement S. Okay. So displacement S is from initial to final. So it's minus 100. So you want to get the time T. So you use this. S equal to UT plus half AT square. So our S is negative 100 and this one is 40T plus negative 9.81 T square. Well, now we have a problem because it's quite a difficult calculation here. We have 9.81 divided by 2. We get this. So I move it to the front. 4.905 T square minus 40T minus 100 equal to 0. Okay, solve this one. Okay, we solve this one. We are using our equation format. Solving equation format number 5. So we choose this one. The second one, number 3. Okay, so we put down the value. This is your A. 4.905. Enter. Now come to B. Negative 40. Enter. And come to C. Minus 100. Enter. So finally we enter again. You get your first answer. Your first answer is T. X here. X first answer. Your T1. So T1 is 10.2 seconds. Another answer. You see? Your T2 is negative 2.0 seconds. And we know that since T must be larger than or equal to 0, so our time is 10.2 seconds. Okay? So don't give time equal to negative. Huh? So you are not going back to the history. B. The maximum height from the cliff. Okay, from here, go up to here. By the time it reach here, the V is 0. See? So we are only looking at this part of the motion here. From here, go to here. So we have initial velocity 40. V is 0. And the maximum height, of course, is our displacement unknown. And then what else you're given? Your A is negative 9.81. So equation is this one. Plus 2AS 0. 40 square plus 2 negative 9.81 S. Okay, so our maximum height from the cliff 40 square divided by 2 divided by 9.81. Okay, so it is 81.5 meter. Okay, 81.5 meter. Okay, next one, C. C1, the impact velocity. How fast is the velocity here? You're given U equal to 40. And then your A is the same, 9.81. And then final velocity is what you want to find. And one more thing, displacement is negative 100 meter. Okay. Formula V square U square plus 2AS. Final velocity unknown. This one is 40 square plus 2 times negative 9.81 negative 100. Okay, we have two answers here again. 40 square plus 2 times 9.81 times 100. Okay, and then square root. The answer, we have 59.7. 59.7 meter per second. But remember, thing is coming down, right? So negative. Okay, negative. Alright. Okay, so this is the example for free fall. Okay, example for free fall. This is our page number 5. Okay, last one for chapter 3. Okay, last one for chapter 3 is the graph. Okay, the graph, how graph represents something else. Okay, how graph represents something else. So I will make it simple here. So this is called the graphical analysis. Okay, 3.5 is graphical analysis of one dimensional motion, of okay, of linear motion we call it. Okay, graphical analysis of our linear motion, okay, of our linear motion. Now we start with the first graph of displacement against time. Okay, graph of displacement against time. So if you draw a graph something like this, displacement against time, let's say you have a graph that looks like this. Okay, so you have three parts of the graph. Okay, three parts of the graph, from zero, O origin to A to B, B to C. Okay, B to C. Now, the graph here, for this type of graph, one information is important. The gradient of graph is equal to the velocity of the object. Okay, gradient on the graph is equal to the velocity of the object. So that means we look at the motion OA. Okay, the motion OA. This motion here, it has a positive gradient. Okay, so the gradient is positive. So that means the velocity, conclusion is the velocity is positive. Okay, velocity is positive. And then the larger the gradient, the higher is the velocity. All right. Now come to AB. Okay, motion AB. The motion AB is horizontal. That means the gradient is equal to 0. So that means the object stop for a while. Velocity is 0 here. Okay, and then come to B, C. Okay, motion BC. For motion BC, okay, for motion BC, your gradient now is negative. So negative means your velocity is negative. So the negative means direction. When this one is like that, meaning that the object is moving to the right hand side, and then it stops for a while and then come back in a negative direction because of this one. Okay, so that means normally this one will be in the positive x direction, this one will be in the negative x direction. Okay, that is how the graph gives us information. Okay, the graph gives us that information. Okay, now the second graph is the graph of velocity against time. Okay, the graph of velocity against time. So let's say you have a graph like this. Okay, the graph, time. This is time and this one is the velocity. Now let's assume again you have this type of graph. Okay, the graph like this, and then you have also three parts here. You have O, A, B, C. Okay, O, A, B, C. Now in this graph there are two information. Number one, the gradient represent the acceleration. You can calculate the acceleration. Okay, and then the area under the graph. Okay, the area under the graph is equal to the displacement of the object. Okay, the displacement of the object. Okay, so now we look at OA. Okay, motion OA. So our motion OA here, what can you tell me? You have a acceleration equal to positive. Okay, acceleration equal to positive. And then for motion AB, okay, motion AB. So our motion AB here, you see the gradient is 0. Your gradient is 0, that means your acceleration is 0 and your velocity is a constant. Your velocity increase until it will become constant, and then finally motion BC. Okay, so motion BC, your acceleration is equal to negative because the gradient is negative. Okay, gradient negative, so that means your acceleration is negative. Okay, so this one the gradient is positive, this one the gradient is negative. Okay, now if I ask you what is the displacement of the object, okay, displacement of the object, let's say there are 3 parts here. This is area A1, and this one here is area A2, and this one is area A3. So under this one, the displacement from OA is equal to area A1. Displacement for AB is area A2, and then the displacement for BC is the area of A3. And then if I ask you total displacement, okay, total displacement is A1 plus A2 plus A3. Okay, so that is the information that we can get from these 2 type of graph. Okay, wait for your exercise.